This is the Chapter 14 Foundation Fieldbus overview by Ryan Martin and Kevin Lucky. The objectives of this chapter will be to describe how Foundation Fieldbus operates, and also remedy problems with wiring, earths and grounds, shielding, wiring polarity, power, terminations, intrinsic safety, voltage drops, power conditioning, surge protection, and how to configure Fieldbus. The outline of this presentation will go with a small introduction to Fieldbus, and then describe the physical layer, the data link layer, the application layer, and the end user layer. Have an area of error detection, how Fieldbus operates with high-speed Ethernet, and some good practices on how to terminate and install Fieldbus wiring. Also, how to troubleshoot the equipment and other errors that may crop up along with Fieldbus. Fieldbus takes advantage of Industry 4.0 standards. Industry 4.0 is essentially another industrial revolution similar to ones that have occurred before, like the 1800s, except the idea behind this, instead of creating factories based around just machines and improving the speed of production that way, we're taking advantage of smart technologies to once again improve the efficiencies and production times, and also reduce the amount of work that people have to put in to create products and services. 4 layers of Fieldbus include a physical layer, a data layer, an application layer, and a end user layer. First layer is the physical layer. It has 2 standards, the IEC standard and the ISA standard. The IEC standard is a number 61158-2. The ISA standard is S50.02-1992. There's the low speed mode that Fieldbus uses runs at 31.25 kilobits per second. This bus supports between 2 and 32 devices that are not powered, 2 and 12 devices that are powered by the bus itself, and 2 to 6 devices that are again powered by the bus itself but need to be kept intrinsically safe. To increase the length and the amount of devices you can have on one bus, repeaters can be used. Continuing on that, at the end of the transmission wires, termination resistors are used to also, these wires should never be connected to ground. Power supplies for Fieldbus need to have matching impedance. The H1 bus response time will average between 32 microseconds and 2.2 milliseconds, averaging in at about around 1 millisecond. There's 4 types of wire that can be used for Fieldbus. These 4 types are types A, B, C, and D. Type A uses 18 gauge wire up to 1900 meters long. Type B uses 22 gauge wire that can be used up to lengths of 1200 meters. Type C can use 26 gauge wire up to 400 meters or less than 400 meters. And Type D uses 16 gauge multi-core wire that can be used under 200 meters. The data layer has a centralized scheduler, and this is known as the link active scheduler. The link active scheduler gives access to devices using a predefined schedule. These 2 types of schedules are called cyclic and acyclic. Cyclic has a periodic routine, while acyclic does not have a periodic routine. How Fieldbus is used is to pre-program and establish frequencies and prioritizations of input-output points. It also allows implementation of services between that link active scheduler and devices on the bus for the Fieldbus network. For instance, you got examples such as a client server with a dedicated client and many servers that it can connect to, or a publisher and a subscriber, or something needs to distribute events like warning events to trigger input and outputs on the bus for the Fieldbus network based on criteria that's already been set up by the user. It also has a messaging spec which is there's an object dictionary which allows access to data by tag name or index number, and can be read from and written to, which allows manipulation of the tags on the Fieldbus network. The user has network management that they can use. They can get access to the other layers, monitor and have diagnostics within devices on the network. You can assign addresses, synchronize the clocks on the devices, and even block the predetermined schedules if need be. The function block allows for pre-programmed blocks used to rid of redundant and time-consuming configuration. This allows for selection of generic functions, algorithms, and generic devices during system configuration programming. This inevitably just reduces the amount of time the user has to configure the Fieldbus network. So, the physical layer's timing and synchronization signaling method is constantly monitored, which is used in error detection. The network and system management is integrated into diagnostic routines. As devices are added or removed, the link active scheduler communicates dynamically without needing to shut the network down. With device description, otherwise known as the DD library, all the diagnostics of vendors' products can be reported, logged, or alarmed. How Fieldbus connects with Ethernet, or can be connected to Ethernet using speeds up to 100 megabits per second. Some good practices for terminating the Fieldnet cable Fieldbus cable is to strip the cable and remove the foil, strip the insulation from the ends of the wire, then crimp ferrules on wire ends and shield wire. Ferrules are small metal caps that if it's stranded wire will allow very easily for one to take a set screw on the bus and just tighten it down. It'll thread into this metal instead of having the screw go into loose strands of wire. It increases safety for the end user. These wires can be twisted together as well and tinned with solder, just like any other wire splice. Shielding wires should not be attached together in more than one place. When installing Fieldbus, system components can be added after the termination is already complete. One should not double up on terminators. Make sure that everything is grounded. And also use a Fieldbus tester to check polarity, power carrying capability, and attenuation and distortion. Make sure that there's no power issues that could destroy the equipment on the network. If any errors can crop up, one of the things to do with troubleshooting is to check the power indicators. You gotta measure your voltages across the network. Look for opens in the circuit, corroded connectors, and even loose connections. If all that seems good, you can also measure the current going through the network and look for any parasitic draws. If issues were cropping up with communication, you could check that all wires are connected correctly. Check that the shield is continuous at the entire system. Check that the shield's grounded at only one place, and that the cables are not longer than their specifications, as stated before with the types A, B, C, and D. If the equipment is to troubleshoot equipment, one can look for errors with the voltage levels on the equipment, noise levels, and also browse the device diagnostics on the network. Few manufacturers have test equipment specifically designed for testing Fieldbus systems. The best troubleshooting device is the actual LED diagnostics on the devices themselves.